Hi everybody, LABLect4, Part 3. You may remember in previous class we came to comparison matrix section. Until here we introduce in the evaluation metrics of the machine learning. Evaluation metrics means when we implement any machine learning, any AI application, we need to evaluate. Evaluate means we need to test. We need to check whether our model is good or not. The tools to evaluate, it is called accuracy, precision, recall, F1 score, ROC, AUC factor. Believe me, this is very, very, very important. And many, even CS students, they don't know. Even many master PhD students, they don't know. Because to really understand of this concept, you should very deeply understand the meaning of these parameters and metrics. In the same time, is very easy, and in the same time, if you watch or if you follow some YouTube or document, if they cannot explain very good, then that makes you complicated. But if your teacher, instructor is professional, can teach you deeply and conceptually. So I am the person going to teach you in very easy way. You know, Einstein mentioned that if you can teach 12 years old or kids, any kids, sometimes he said 12 years old or sometimes said kids, if you cannot explain any concept, it doesn't matter, computer science, quantum physics, and in mathematics, if you cannot explain to the 12 years old concept, that means you don't know that one. So you cannot say to your friends, I cannot explain because that is very complicated. And you cannot say, oh, my major is not computer science. It is very difficult. Oh, no. If the professor knowledgeable, if your instructor is professional, and if a student really wants to learn something, this is the point. If really a student are not serious to learn, make an issue, oh, it's very complicated. This is my major is not a computer science. Oh, very difficult. No, this is not good excuse. Because the way I am explaining is very simple. I deeply understood the concept, and based on the Einstein, if learn something, I can teach you. Kids can understand. Why not you understand? So get the hope and be optimistic, not pessimistic. Try to learn it. So from today's lecture, you may at the beginning feel it is very complicated, but the way I am going to explain is very simple. Very professional. You know, I spent too much time to find a good material, and then I found those material is not good. Then I create my own material. Every figure I made by myself, every text. So it took a lot of time to prepare my slides, especially today's slide, because I know some of you is non-CS, from other department. You may feel difficult, so that's why many times I change my slide. So maybe 5 version I change this slide. Many times I was thinking, can kids understand my concept based on Einstein formula? If the kids understand, so even non-CS student can understand. So believe me, this is very easy way which I'm going to explain. Before we dive into, this is the techniques when you make an AI system, right? Any AI system, we cannot say this is the best. You should prove it. How? Use some international accepted formula. This is the formula. Formula means metrics. Professor, I don't know metrics. Do you know the ruler? Ruler. You want to measure something. Do you know testing? Yes. So we would like test our AI Is it okay or not? Prediction, it is okay or not? AI is going to predict, learn something, right? Learn through the system and predict something. This is the AI. You may remember from the pyramid, the going this way is more intelligent, more learning implicitly. Okay, so before I start here, let me quickly summarize what I already taught few lecture before. Maybe that would be good for some of you. Always reviewing is good. So let me back to the first slide. So in the lecture 4, when we come to the lab lecture 4, more practically, more hands-on exercise than theoretical part. When I put the lab before the lecture, means I am going to do some practical activity. So in the machine learning, this is including machine learning and deep learning, this slide, but I put just machine learning. But you may remember machine learning is a bigger part of deep learning. So that's why in this lecture, try to do finish everything regarding the machine learning and deep learning. Then we will go for big data, which is last part of lecture. So far, we cover many information, history about the AI, and also big data. We concept history we already cover, and we will coming weeks we will touch some exercise for big data, and then we will finish this semester successfully, cover whole syllabus which I promise you cover during this semester. So let's quickly recap what we already discussed. We talk about, this is very good slide, many times we refer to this slide. Problem solving, we already talk a lot these algorithms, cover all of them, talk about everything. This is usually based on the old techniques, which is look at everything explicitly, means openly. We see problem step by step through some algorithm we teach computer. So this is the history, we already talk everything about them. And then we came to the second part, little bit more advanced one than problem solving in the AI. It is a knowledgeable and reasoning. That means here from data part, then we come to the information and knowledge part, this part, which is here, approach 2. We talk a lot about the logical agent. I am reviewing. First order logic, you may remember, right? What is the difference between logical is based on the simple logic, and little bit advanced one is the first order logic, and then the other decision making. This is knowledge representing. And more, this is number 4, which is more advanced, and we will see in, for example, theoretical part plus, we will go for AI and big data combination later on. This is 4. The reason I put 4 here, because the 3 is big one. I want to unite it in one page. I designed this table and by myself. I spent too much time. Put everything. Always when you have this figure, you will remember my class. And this is very unique table. And you may see many books, many presentations. You look at this table, you will know, oh, machine learning algorithm, this is the including supervised, unsupervised, reinforcement learning, deep learning, blah, 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 like this. This is deep learning. And the advanced one, all is a deep learning. This is machine learning. All is a AI branch tree learning. So we came to this stage. So many of these already covered by Orange software. Some of them we will practice, and some of them I will give you exercise 3 to touch, working with visual programming for AI and deep learning. So through this part and Orange, you can do deep learning and machine learning. We will cover everything in a very simple way. Then we start talk about the machine learning, deep learning, supervised, unsupervised. Then deep learning, a little bit go step by step, close to practical. And then when I come here, a little bit more practical, and then this wonderful table. Last time I told you, this is wonderful paper. Really, I enjoyed this table. I didn't see any table like this table. Very wonderful. And please remember, print it, take a picture and print it and have it and enjoy it. This is including AI, all algorithm, machine learning and deep learning. And with the orange, one by one you can exercise. Already, for instance, in the last video, I focused about this one. Orange has very easy way to understand the other. You know, this figure only, there is in the world, only one semester they touch to this semester, to this table. So if we work with only orange, with some Google notebook, Jupyter notebook, it is enough for one semester. But since in this semester I want to teach many things, so just I define the structure, some assignment, some class activity, and some project. Then you will come to the some level. After final exam, after finishing this class, you feel, oh, you got the line, you got the path, how you can learn and learn and learn. Okay, we talk a lot about this one. What is the classification? Main concept. Even many PhD student, because I have a PhD class, I have graduate class, I teach to the PhD student, they don't know. Even PhD student, because they don't have a good material. But I prepare very easy way. As I told you, if you want to create the best material, should be easy way even kids can understand. So this is the way during this semester I explain. For detailed one, you should little bit practice, and hopefully in the future you will improve yourself. But main concept, it is enough learn in this semester. So we already talked, for example, supervised classification, They call it classification, but here call it unsupervised clustering. But meaning same. Regression, same meaning, means return to the main group, means coming to the average and come to the world. When they call it regression, that for the first time they measure some people, boys and girl, and they said if the boy and girl parent, they are tall, then the kids should be tall. But for the first time, they introduced no. The height of the kids depend on society average grouping height, not depend on the parent height. Return to the mean average group of people. The word of regression come. So this is the point. So again, some clustering insight. But here, using some for the logistic regression, we use usually is data is like this, and another data is like this, and then usually the figure is a probabilistic is like that. But this is the logistic. But in the linear, data is you already saw data is going this way or going that way, and you say, okay, this data is the representative of whole data, right? And this is the representative another data. So this is the linear, but the logistic is using the probabilistic. So usually shape is like that, and then you have a threshold. So everything in the later on also we will talk about the threshold. Association same. This is same again. Grouping PCR grouping. But the decreasing complexity to make simple grouping. And same reinforcement learning, including task-driven and data-driven here. But this is both. But this is based on optimize action to maximize rewards. This one. So through this table and this is make just same. I divided these two parts, supervised, unsupervised, And deep learning, same. Deep learning including tasks, more layer, simple one ANN we already discussed. Little bit CNN, and when you are on label data, this is label data. See, this is not like supervised and unsupervised data should be labeled on unlabeled. Both is possible for each one. Sometimes label, sometimes unlabeled. So this is a recognized pattern in a complex data. So this is used for computer vision application like autonomous vehicle. This is usually for NLP, use it for language translation. This is for fake because generative adversarial network is generate realistic image. Many GPTs like deepfake can use this one. And transformer is exactly for NLP, natural language processing. Use this one. Many chatbot is like that. So this is just quick review. You remember what's happened. Of course, you can watch video for more information, but just I want to review this one for your better understanding. So classification, clustering. We already talked what is difference between supervised learning and unsupervised learning. About the interactive tools we practice a lot, and then we introduce very visualized environment programming. Then some teachable machine. So we talk about syllabed score, which is important already in the previous to know whether this group, for example, if you have a data like this, so you don't know this is one group or this is one group or one group to see this is good separation or not. So you do, because clustering, you have it one way cluster, all is one or separated. So this is the scale. If some data is very clear, one data you have here, another data you have very far from each other, so easily you can say this is one cluster, this is one cluster. And machine learning, all is grouping. Remember, we already talked a lot. All is grouping. All machine learning, deep learning, try to make a group, because in the group you can learn something. This is the point. In the group, you can learn many things. Our society is like that. Many people hesitate to make a group. Some country, Asian country like Korean, Japanese, Chinese, they make a group, make a successful. So make a group. When I ask the student, make a group, they hesitate. Oh, we don't like, we want to. No, make a group, you will learn. So if you ask me as an expert in the AI and machine learning, I will say all AI, machine learning, all is grouping. All means grouping. All is grouping. All of them is grouping. But the way of different group, more intelligent, the type of group, all is grouping. So, if all is grouping, syllabed is one of the example. Try to say, okay, if the data is grouping, can make a group, because if I make a group, I will learn. This is the goal of AI. So syllabed said data is very far and clear. Syllabed is close to number 1. If this syllabus of this group, this syllabus score. Pronounced is syllabed. And so this is nearly 0, or if very close is -1. Very nice index. You should think about, maybe you introduce some techniques and put your name. For example, your name is Aziz Beg. Your name is Kim. Your name is any name. If you introduce some solution, maybe we will call and we will teach your name in the class. Okay, this is the X score. That X can be your name. Why not? If you deeply try to understand the concept, you will learn it. Okay. Then we came about the workflow, because we are going to finish the machine learning and deep learning soon. In every machine, when I'm saying machine learning means deep learning, machine learning, AI, same workflow. All is including all of AI. If you ask, I want to make a good application. So what the step we need to create? For example, you want to make a project. So I teach you first what you want to do, what data you need, because most AI application is the data-driven approach. Please, I am many times repeating here, this we already talked, data-driven because it starts from data. Most algorithm is data-driven. Most like deep learning, everything is the data. So then we need to do the data collection. Then data processing. When data splitting. All is a data, related data. So after you define. So for data processing, cleaning, transformation. So then we need, okay, model means I want to continue learning. Because if you have a data, you learn something, you say something from data. But if you make a model, here you need to go to the detailed data to get something. But if you, from data, if you make a model, then you don't need to go from scratch. You can ask from your model. It will be like computer, like human, this model, which is created based on this data. So if I give another data, another result come. I don't need to do all previous data processing to create model here. So this is the meaning of model. This is one meaning of the model. Another meaning, let me, based on the, you may remember, based on the conceptual concept world. We have a physical world. We have a cyber world. You need to bring your physical world elements. For instance, you have a road. You need to bring the digital road here. You have a building. You need to bring the building here. You are human here in the physical world. Then you need to make an avatar, digital character or avatar in the cyber world. So here, how to bring is a model, this one. Wow. Another meaning of model, another name. Can you tell me, please pause the video, tell me what is the another name of the model? That is representation. Representation. This typing is by mouse is difficult. So model, why representation? Because in the physical world, we have everything, human, building, mountain, road. We have you remember, an environment including three parts. Either nature, man-made, so nature, man-made, and human-made and human. So human one, building is a human-made, and nature, road is a man-made, like mountain is a nature. So we have a three element in this world. So environment including three, human-made, and nature. So these three elements are present. We need to again present. Again means represent. So that's why represent means modeling. Another word for modeling is the abstraction. Actually, not only I am reviewing previous lecture, but also adding something. Wonderful. So while I am reviewing, I teach something more. Abstraction or abstract. Why they call it abstract? Because in the real world, everything very complicated. For example, if you take a picture from the mountain has a lot of detail, parts, like this. But when we bring to the computer, this one, through our model here, how we draw it. This mountain easily I draw like this. Very simple. Don't go for detail. We make it abstract. When you write a paper, the short explanation of whole paper on top of the report and abstract, we call it paper, in the top of paper, we call it abstract. So that's why representation equal abstraction equal model. Then after we make a model, we need to tune our model train, and after here we need to evaluate. If we don't evaluate, for example, if some company like Tesla, like Hyundai, like Toyota, they create car and then without checking, without testing, send to the market and people drive and kill many people. So do you think this is acceptable? No. Everything needs test, whether okay or not. Even if I teach no exam, no meaning, because we need to test whether did you learn, did you attention. So everything needs test. So model test, same. So we need divided our data because data is limited. For evaluation, we need also data. So the rule is if we have a data, we divided mostly, usually 70 to 30%. 70 we use train our model to create model. 30 use as a test data. We will use as a test. Okay, let's continue. Yes, we pipeline we explain when we evaluate, then we can inform, okay, everything is ready. We can through the website API introduce and then take care of editing, modifying, which is called maintenance. Add something based on the user preference. And now is a main part of class. Almost it took long to review, but during my review I add something new concept to really understand accuracy, precision, recall. So what does it mean? Really, I spent too much time. It's very difficult to teach this part. If all of you were computer science, it was easy for me. But since you are half is the computer science, half is non-CS student. So even for I know some of non-CS student, they know very well. But anyway, if I go for an easy way, that guarantee everybody follow the instruction. Okay, let's before diving into the meaning of that one. So try to guess accuracy. When you say accuracy, it means okay, how much is accurate? But precision, how much something precise? Same. So what is the differentiate? Please don't look at this word. You will confuse. I will teach later in detail. What is the recall? Recall. What is the F1 score? ROC. Why we need this? So whenever you refer to the orange software, you will see this 5 index. And each one has own responsibility. So you need to learn each one separately. Now let's start. First step to understand evaluation metrics and how we can use those evaluation metrics for model prediction and model evaluation. You need to understand when we have a data, because you may remember every step starts from data. So we will make our model. You may remember here, I already mentioned, that is we define the problem. For instance, we are going to design machine learning to detect coronavirus infected patients. So we define that topic and then we deal with the data, right? From the data, we will make two things. We will make a model from data, we will evaluate model. So data is important. Okay, great. Let's back to our main. So we have a data. When many people, many books, they teach about this index, accuracy, prediction, recall, they talk about positive, negative, and then they will talk about some terms which I'm going to show here, like many terms like true positive, false positive, false negative. So this is very confusing. So I'm going to teach you very easy what does it mean. This is when they want to calculate accuracy, they will use this term. They will say this plus this divided this is accuracy. This plus this one is a recall. This, so is a positive, true, false, what does it mean? So before you understand what is the accuracy, what other means, other metrics means, why they call, many questions come, why they call positive, negative? Positive means good, this is bad. There is 4 terms. One is the true in for index, for metrics. One is the false. Main problem which you don't understand, you cannot recognize what is the meaning, why they are using this positive, negative, true, false. Why 2 parts? Why data divided 2? Why not divided 3? Why not? Many questions come. Why they said true? Why they said false? So I'm going to simply explain to you in a very straightforward techniques. First of all, when they want to try to use model evaluation, they need to consider 2 categories. Maybe some of you ask why they don't call category 1 and category 2. Why they are saying positive, negative? Because the answer is because of probability. Because they want to show something is much important for me. For example, they are saying predict whether someone has a disease or not disease. For them, disease is very important for that machine learning, so they call it positive. Other thing, model to distinguish and separate it from the non-patient, it is negative, means it is not my target, but it still exists. So you understand. So you can use category 1, category 2. So divided data 2 part, category, you call it category 1, category 2. So no problem. But the problem, if you use this one, many other definition of the probability will be mixed to this and not understand well. This is very close to probability concept. And another main reason, this is international terms. Many scientifics, let's say all scientific use these terms. But this is the main reason, positive, negative means the data, some portion of data which is positively, which is close to my target, main target. I want to use machine learning, AI, artificial intelligence to recognize a specific target from the other which is not my target. So it's negative. So both is a data. So it's not something error. So this is very important. Many students ask this question or try to memorize. If you don't understand this, you will not understand the really pure and exact meaning of the model evaluation. So I'm teaching very low level and very simple. I don't pass quickly this slide. I am explaining from different aspects to you to learn it. Okay, I think you got it. So you can put category 1, category 2 is okay. See here, this is some sort of data, means these people has a, you know, based on the probability, data usually is a Gaussian data. When you have some sort of data of some student, is not the same for all. Is when you plot, you know that why. This is a Gaussian concept. So any data usually shape as like this. So in one class, you cannot find every student top. Some student good student, some student middle, some student lowest. So this is the always. In a society, some people are smart, some people middle, some people low, IQ. In a, for example, in a company, some people they are has a manager job. Some people the capability for moderate job. Some people labor job. This is always for any sort of group. In among your friends, some of friends is very kind, some of middle kind, some of not kind. So this is the type of data. Shape is like that. And for negative, like this. And there is some sort of share area. We define the threshold. So usually data shape is like that. This is based on the probability and statistic concept. So we are not going to teach those. Just I want to say positive, negative, what does it mean? What is the true or false? So true means okay, very simply, means right. False means okay, means wrong. What does it mean? Means when I define some AI algorithm to do something to predict, I define some AI algorithm to predict car plate license. So at the beginning has some error. If you give 100 car plate license, maybe 90% right and 10% wrong detection at the beginning, at the first training. So true means this is exactly same as the reality. True, reality, actually, this is actual thing is a true. False means your model cannot detect very well. So simply, you may ask, accuracy or model evaluation simply means number of true divided of total number of false and true can be evaluation. Yes, this is true. How much your model is answer right? For example, you 100 license plate you give to the system, your model, 80 right. You could say 80 divided total number of plate is 100, right? 100 means what? 20 wrong plus 80 right. True. So true divide, this is the I want to evaluate. Yes, you are right. This is exactly first category, accuracy. Accuracy, first index. If we go to here, accuracy is that one. I will explain why we do not use only accuracy. Why we go to, because accuracy sometimes has an error. I'm going to explain. Yes, simply is like that. So using the number of right divided whole, this is, we can say my model is right or wrong. Yes, but sometimes this formula doesn't work. So we touch to another technique. So I'm going to explain. So you understand positive, negative, true, false. So let's combine together. In my group 1, let's say category 2, when I am going to use that some corona patient, not corona patient, heart disease patient, not heart disease patient. So when I define some AI, of course, in this category will be detected corona patient properly. What does it mean? Properly means true. And sometime in my another category, category 1, negative is not bad, means vice versa, the other side is true. This area is a true. So number of corona detected model recognized based on the, for example, chest X-ray. You have an image of chest X-ray, you define some AI model, give to your model, and your model, how you know? your model choose this chest X-ray got a corona, and then you go to the documentation of that person using another way of corona detection by using something inside nose detection directly manually, not through the image of chest, through some sort of devices put in the nose. They detected this person has a corona, and your model shows that person corona. So that means you choose that person has a corona, and truly those another person you choose does not have a corona. So true. To differentiate between this and this, let's say put P means group 1, group 2. Wow. So TP, TN means true positive, true negative. So please pay attention. It's very basic. I'm going to explain. TP, TN. How you understand when you see T means true. P, do only attention P and N negative. Positive means category 1, category 2. So let's continue. Another data I'm showing, for example, with a black one. Some portion of result showing that this person has a corona image. My model shows from the chest X-ray, chest X-ray, or chest CT image. That image using showing that my model shows this person has corona. But when I call to the doctor or check the documentation of that patient, I found out with another technique, doctors found out that this person doesn't have a corona, but my model shows this person has a corona. So this area, this area. So this area TP, but that area is false. So here is also false, this area. That means your model shows that this person doesn't have a corona after model checked the image doing some computer vision AI-based algorithm, but doctor opened the document of that patient, shows this person has a corona, but your model said here, so that means false. Error of your model for group 2, error of model group 1. To make differentiate, you put the P. So P, here put N. NP means group 1, group 2, remember. So we have a TP, TN, FN, FP. So you don't confuse now, very clearly. If you don't understand, pause, back, and listen again, because I cannot repeat. If too much repeat, for who understand, that would be boring. So now you understand. True means right. My model successfully. TP means my model successfully. For group 1, for example, it doesn't matter group 1 or 2. For example, here, if this is group 2, this is group 1. Okay, my model for group 2 successfully give right answer, but has some error. False. You know, false. Right, true, false. True is reality. It is better than right. The reason they didn't put right, because true means to the reality, to actual data, actual, patient. So true is much better showing the reality. False means this is not fit to the reality, some error. Every word has many concepts behind. There is some question, some of students ask one another important question. Now you understand TPTN, FP, FN. So, great. So, remember, this is when the corona right. This means, if I draw the right one, it is better I draw the right by some color. So this is the everything right, okay, all data. So this sort of part means totally TP. So there's some portion of data which showing this has a coronavirus, but showing this doesn't have a coronavirus. That means here, because going to this category, but actually this belongs to this category. I will show by another drawing that makes very clear. But for now, just believe me. Okay, now I am going to open another challenging question. Why we divided category 2? We said some has a patient, some doesn't have a patient. So if why don't we have a 3 category? Why don't we have a 1 category? Why we make a 2? This is really technical question. It's not easy to answer. If you ask, anybody cannot answer you, but I will answer you, don't worry. Because most classification type is binary classification. 0, 1, black, white. So because of binary is 2. Another reason, if we use another sort of category, I will show you. I created and I made by myself very nice table. I will show you when that is not binary classification, what would be happen. And most AI algorithm, and most specifically supervised machine learning algorithm, is a binary classification. So we divided 2. Another student asked another question. I will tell you, pause the video and answer. So if we have a, for example, dog, animal. Please find from many image of dog. And in not dog means that image is not dog, but is a, for example, refrigerator, is a car, is a human. So since our model is going to find dog, all category we make as a not dog. Why? Because our goal is find the only dog animal. So what is the answer? So if we have a many data, we will divide it to that specific data, means dog. Other data we will call not dog. For example, I have a data for many nationality student, like from Iran, from US, from Uzbekistan, from Pakistan, India, Kyrgyzstan, from some European country, Malaysian, from many, from Nepal, many country, from Germany, which I had a student, Switzerland, so many students. When I want to make an AI, I am going to say I am looking for only Iranian student. So then what? Also many category. I will do binary classification. I will say positive is Iranian student, negative means non-Iranian. All category, all nationality will be under this one. If I am looking for Uzbek student from Uzbekistan, then others including non-Uzbek. So please understand, easily 2 category. So easily we have a TP, TN, FP, FN. Okay, I think professionally I explained. So I put something binary classification. Why? Because this is simplified. I am looking for dog, not dog. Easy for matrix calculation. Easier to analyze. So binary we have a 2. Why not 1? Why not 3? So if with the 1 category we cannot. For multi-classes, binary classification will be preferred. Or we need to, if we have a multi-categories, either depend on the type of machine learning, we will make a binary, or we will use another matrix. So I'm going to explain shortly. This is not our main topic. Okay. So just quickly recap, you have a classification, regression, clustering, association. As you see, mostly these are classification, and regression and clustering. And this classification binary multi-label and multi-category classification. So binary is the most of this is based on the binary classification. See my next slide is very clear. So let's first show this table. So here, most algorithm, supervised classification and then unsupervised classification, this is deep learning, mostly is a binary classification. Also, they are using multi-class or multi-label, easily can do classification. Some exceptional case like hierarchy is only hierarchy classification. And some algorithm basically is based on cluster, like this or like k-mean, this is only clustering. Or some regression, like linear regression, only this technique. But as you see, most is deep learning is the binary. So we or binary or we can use binary. So that's why it's 2. So in the previous slide, here I explained binary classification, data divided to 2. And in the multi-class, more than 2 possible. But we need to use like whether sunny, rainy, or snowy. But these algorithms, most of them also can use classification as you can, binary classification. Or multi-label means each sample can be belong to more than one category. For these, each one we can use different sort of metric. But today's lecture is binary. But just I explained there is another classification. Like accuracy, recall, FM1, ROC, precision, all is here. Here also use same plus some other. Here use including same, some specific, but we don't cover now. It is very advanced one. So here we have a imbalanced classification, hierarchy classification. Ordinal means based on the order is important. Cluster and regression. As you see here, all of these 3, you can pause the video, read this. In this table exists. I make summarizing these 2 pages here. So based on this, you understood. So why we have a binary 2, and because we usually when we do AI, we are looking for a specific target. Okay. So classification model. A model that predicts whether corona or not corona, disease positive, not that disease negative. This is example. So I already explained very well. When, TP, you remember TP means true, means my evaluation true. My evaluation true. TP means true for group 1 and TN means my evaluation for group 2. So this is set correctly, predicted group 1. Main target positive. TN correctly predict group 2, but this is not my main target. I put negative. FN, from F you should understand this means wrong. Wrong for what? For group 1 TP, wrong for group 2 FN. Right. See here, as I mentioned, TP, FN, FP, FN, TN. And this threshold can be, we will talk, this is good for ROC calculation. Why? Because if I change threshold here, then amount of the FN will be decreased. This is the FN. And then what happened? The amount of the FAP will be increased. Depending on how threshold moving, amount of the FAP, FAN will be changed. So this one, I made 3D. This is better understanding, cutoff. So when you change this threshold, true positive means main, we are looking for sick. So this move means you will, when you this threshold move this side, you see the value of a FAP increase, value of a FAN will be decreased. So this is the result situation. So after many explanations, you understand this is okay. This false, they call it error. That's why call it error. Because our main target is positive, they call error 1, type 1 error. Type 2 error is a first category, for example, another case. Main category is second category. P means disease, corona, not negative. So remember dog, not dog. You consider N as not as a negative. You consider as a not to remember. So both is error. What is this? This is very important. In the machine learning practical part, I already explained the orange, interactive, visual environment. I will also touch little bit for Jupyter Notebook. You will see this table. This table is very important. It is called confusion matrix. So what useful they are? Because these all separately has a meaning, but we want to compare together and consider together. In that case, we put in a one matrix. What does it mean? Actual class, predicted class. Actual class. So in actual class, we have a in a reality, we have some data, group 1 class, main class, second class, right? We have, for example, dog, not dog. As a human, we can recognize. But we will give to the AI model. AI decided we know who has a corona because we don't check only based on the image. We use another way to see when we know that data corona that person has, but our model make different categories. Say these people has a corona, these people not corona. So if my model predict right, we will call it TP. Means actual data predicted as a group 1. My group 1 data, my corona system choose as a corona. We call it TP here. We bring here. Group 2. Because group 2 here, my reality said not corona. Here also my model choose not corona. So these two is correct. Let's make it with a color. For example, blue is correct. And these two is a black. My model saying this has a corona, but in the reality has a corona. My model shows not corona, so it's false. FN. My model shows group 2 means negative class, but the model shows in the reality is group 2. Model shows group 1. So this is 2 wrong, and this is right. So this is confusion matrix. So based on that, they can understand totally how is happening. Confusion matrix is very useful, specifically for ROC index, for accuracy, for recall, for precision. We don't need confusion matrix. So this matrix is useful for ROC and AUC. I'm going to explain simply in coming slide. So, in confusion is I already explained. Actual classes predicted. This is already talk. This is designed by myself. I thought how I can explain simple. Then I decided to draw this figure, and even color has a meaning. Many times when I try to create this one, I put many colors, many shapes, then I change. Maybe it took to these 3-4 slides took for me more than 3 hours. Every time I change, I was thinking maybe for new student they confused. Let's add more this. Basically, in my main slide doesn't have these sort of figures. Then many times I changed, draw. Finally, I came to this slide. So please, just I would like to know the value of these slides. Sometime preparation, one video, it took, for example, for 1 hour recording video, usually minimum 5-6 hours it took. Sometimes I record, then I found out this is not enough. Let's add more, change the slide. So let's explain more this part. So I am really worried about you. So please study well and appreciate my effort by study. Okay. So let's say these people in the reality, they have a corona, and these people doesn't have a corona, because I already told positive means group 1, main group, and our main target, find who has a corona, who infected corona. But the problem is, in the reality, we know who has a corona. We want to use machine learning and AI, that machine learn. Maybe some of you ask, hey, you know easily who has a corona, who has a not corona. Why you want to put AI? Make it complicated. The answer is, for few number I know. But when 2 million patients, so if I make a model for few number like this, and then I can put X-ray of 2 million people, even who I didn't meet them, who I don't know whether they have a corona or not. If my model trained very well for a small data, sample data, then I can find for 2 million people based on only X-ray image. This is the concept behind of AI. I am creating the human with a great knowledge, learn them with a small data. After evaluation checking using this index, that can be for big data. I hope you got my answer. Okay, so let's say, for example, my model, I can use some magnifier like this. This is, let's say, my model to show from the main data. Okay, let's do. I designed very nice to find this one. Many figures I tried and many texture. I found out this is very pretty, and it looks like model prediction from some data. And even color, many times I change color. It takes, I remember only design this, it takes 2 hours. Many changing. And even color. You know, I put a color like T means true. I put a green. This is means true. But yellow is similar. This is the yellow means not corona. I put yellow. This is blue means corona. I put blue. So blue. Here N I put red, yellow. For wrong I put a red FN. Here put a F. Wow, very nice figure. I love it, really. So that means after I designed my AI, I found out my AI model. You know, you should use in the assignment also. You should use this sort of explanation. For example, this is corona. I know this has a corona, but my model shows this doesn't have a corona. Right? Showing doesn't have a corona. Doesn't have a corona means yellow. Falsely showing yellow. My model shows, because my model is to detect corona. Showing I already detect corona. So I know in the reality yellow doesn't have a corona, but showing in this border means my predicted this 3 sample has a corona. Has a corona means P. But Actually, this is falsely detected as a P. So this is the Fn. This is successfully, my model said this is group 2, not corona. Yes, truly not corona. And I know not corona. I think you already understand the concept. So this model is basically looking for only corona. So please pause the video and answer. If you were in a class, at this stage I ask you how I evaluate. Evaluate means check, test. How check my model is true? Maybe you could say yes. How much you are right? Correct answer, total number. What does it mean, correct answer? So this blue has a corona. In the reality, my model also shows corona. Oh, so this is truly. So TP plus this, my model shows has a corona, but actually doesn't have a corona. Yes, this is wrong, not my model successful. Here, I know this has a corona, but my model shows not corona, so this is wrong. So not good. My model, in the reality, they don't have a corona, and my model also shows not corona. So this is good. So total means total Tn plus Fp plus Tp plus Fn. Fn. So all sort of possibility, right one. You may say, oh, this one. Yes, you are right. This is accuracy. Wow. Accuracy means this one, right one, this one, right one, divided to all. This is accuracy. So let's check. Let me keep this one. And I want to show the formula. I want to keep this formula for, yes, this is accuracy. TP plus Tn, whole, this is accuracy. Mean in whole area, I consider which one is right. This plus this one. This is accuracy. But accuracy has some limitation. What is the limitation? If our data unbalanced, means what? For example, if we have a data set, only 5% corona, for example, if we have 100 people, real data, 5 people has a corona, 95 not corona, is not balanced. Then what would be happen? When I run my model, so total is 100. So even choose, for example, choose 95% negative, couldn't detect any corona. So what would be happen? Here would be 95 because it will be Tn. So that means my model 95 accuracy, but actually even didn't choose any corona. So it's basically is wrong. I am looking for corona. My target is a corona. Because of this formula doesn't works for imbalance. So here said very good model, 95%, but actually even couldn't choose one corona, my model. So this is not good metrics. It's not good index. So then researcher, then they think about what we can do. Another come. Another. What can you tell me? Please pause. If you really can tell me, please pause the video. Even you wait 1 day, even you wait 2 hours to answer my question, you will be good student. if you can, recognize my answer. So can you make a new formula based on TPTN to more accurate one? Please wait, please pause. Minimum 5 minutes, 10 minutes, 1 hour, 2 days. Think about, give me new metrics. Okay, thank you for pausing. Thank you. You already worked for 5 hours. And now continue. Like not only a student, I'm asking you think about, I'm as a teacher, many times I teach this concept, but every time I try to change my slide, the way of explanation. So every time creativity, innovation, that makes you unique professor, make unique student, unique researcher. So this is the meaning of the real researcher. I highly encourage you for be unique in the world, find a good company, good master degree, PhD position. I encourage you to do this way. Future for yours. You can find a good job. Use your mind. Be brave enough. Pause the video for 1 day. I am saying you, for 1 slide, sometimes 4 days I work. Change a slide because I enjoy more than you. I can make some PPT quickly record video send to you. Who wants to say any problem with good quality? But good quality is not good for me. I am looking for best quality. So you should do, I am doing. So that's why I'm asking you. I am begging you, please do like this. If, teaching is one thing. In addition, teaching, I want to tell you some important things. So, let's go. I already believe you after many things. This is the innovation. Innovation in a study, this is the meaning. Then, what happened? You will find some formula which not including the formula which I introduced. Then what happened? You can record that method as your name. Okay. Now, let's go new sort of metrics. Because we found out that accuracy, it is not good. So let's go with a new one. You already think about it. So what is the another one? Okay, the name is precision. So can you please pause the video and tell me, give the formula. For example, you say for FAP divided FAN plus TN something. Give the formula. And tell me what this divided to this. Or tell me this divided to this one. If I show with a different color, for example, you said, okay, precision means the number of FAN divided number of this one, right? Or you may tell me, no, number of the yellow divided number of blue, or vice versa. Or you may tell me the blue divided to FAN and FAP. Or you may say, okay, T means true. This is true. So all true divided whole data. Or you may say, no, all false. This is false, right? F. Here, F. All false divides the whole. Or you may tell me, no, professor, all predicted area we are looking for corona means positive, divided whole data. Or you could say, no, professor, we have another idea. All FAN outside of the predicted area divided whole data. Or you may tell, no, predicted area, right, divided to the wrong area, this one. So green divided orange, or orange divided green. Or, I don't know, do I repeat it or not? I don't attention, just if I repeat it, it doesn't matter. Blue divided yellow, or yellow divided blue. So this is, with this sort of thinking, we can, go for the right decisions. So this is the right decision. So you need to pay attention. So for example, for accuracy, it was total, here total TP plus Tn, this plus together, divided whole, that this blue line. Maybe this is, if I change the color, means the red divided this blue one. It means accuracy, because T is true, divided whole, this is the accuracy. So now this is the accuracy, right? I want to know what is the precision. So in the precision, they said, and they think little bit specific. In the precision means what is our goal. So the difference between precision and accuracy is, instead of attention to the whole true result, because in the accuracy, true positive means corona detected and not corona detected good. Who is not correct? My model choose who doesn't have a corona correctly, because this is wrong. Corona detected, this is true, this is error. This is the first error, this is the second error. You remember, right? We already talked here. First error, FAP first error, FAN second error, FAP first error. So FAP first error, this is the first error. Why first error? Because my predicted model, only I am looking for corona, the blue, this magnifier. This magnifier is my model. My model, I am looking for only corona. So precision said, only pay attention to the corona, positive class. Although this is true detected, but I don't care, because my goal is only positive, my main goal. So instead of saying TP, Tn divided, so if you bring the target saying I don't care about Tn, although this is my model detected properly, but is okay, but I don't like, only through my magnifier, my model I want. So this is the Tn, remove, only TP I like it. Then when I focus about the TP, because I want to focus on my model, I don't want whole data. So no FN, no Tn. Only I want in the magnifier, whole magnifier. So TP, so remember, TP divided TP divided FP. Is not good, because I want to keep for next slide. So TP plus, maybe I can say the formula very quickly, memorize it. I don't want you memorize. Deeply, I would like to you understand. TP divided TP FP, TP FP. So only through this magnifier, my model, this is my model, only corona. So this is the precision. See, if I just move precision, only P classes. So see here, TP divided FAP. Only here. So, yes, only here. Then I use TP divided blue one. So this is the, then after some time, they thought, if corona is important, in the precision we said how much in our model corona means P. How much are P detected well? Then another person said, why don't you say how much TP compare not corona detected? This is also good. Still focus is the corona. So that means TP, instead of divided here, focus to the model, focus whole data, whole corona data, whole P data. Then divided TP plus FAN. This is another name. This is the recall. Recall. Somebody said all. Remember, all means all positive data. All positive data recall. So difference between precision and here TP main target successfully how much corona detected. Yes. But in the precision said inside my model, but in the recall said inside whole P data. Then sometime precision go high, sometime recall come down, sometime both go high. Then somebody said, oh, which one is good? Precision is good or recall is good? Then another thing come. What is that? Can you tell me? Another matrix. Combination of this and this is FA1 score. And then, confusion matrix, we already explained. Confusion matrix, you remember, right? This confusion. When you use the confusion matrix, is mix of all. Then, if threshold change, confusion change because this value change. Then, confusion makes ROC because threshold change. ROC same as AUC. ROC and AUC same. So finish. Quickly I finish. But I will go detail again. But I want to recap. Let me come back. Okay. Just quickly remind you. Here we said accuracy. We said yes, accuracy means the right one to whole data. Precision said no, only P right one to under model. Recall said P positive on not model, on whole P data. F1 score said no, balance between precision and recall. ROC or AUC saying many FAP, TAP, FAN, TAN, confusion matrix, maybe threshold change, then we need draw some figure. This is ROC. Mix balancing of all of this. So growing matrix more professional. That's all. Let's go inside. I think for this precision, we already mentioned. This is the all true means all. All P class true. True means actual. P class only blue. This divided to this whole. So that means TP divided means divided whole. That one TP divided whole. So this is the recall. Great. So I will continue more detailed one in the next video.